A new study shows something amazing. It looks like our galaxy and we are both parts of a bigger structure in space that has just been found again. This could mean that everything we think we know about time and space is wrong. We are not lost and alone in space. Instead, we float with hundreds of thousands of other galaxies in a huge cosmic stream that is headed straight for something huge and impossible to explain. With a width of 93 billion light-years, the known universe is like a huge beach that is about 10,000 kilometers long. Our Milky Way is like a single grain of sand on that beach. Still, the Milky Way is a very interesting galaxy. It has a width of 100,000 light-years and between 100 and 400 billion stars inside that. We, the people who live on Earth, are a very small part of the universe. Now picture that the biggest structures in this cosmic beach are about the size of a seashell or a bigger flat stone. Since a few years ago, we've known that this cosmic dance is like a huge ocean where galaxies move in a straight line. They move in loose groups, all going toward a strange structure scientists call the Great Attractor. At least for a while, it looked like our part in this cosmic dance was clear. But now, brand new pictures from the Gaia satellite are making us question everything we thought we knew. We are probably a part of a structure in space that is bigger than our brains can comprehend. We are not part of the Laniakea supercluster, as was once thought, but of a much bigger structure. This word comes from Hawaiian and means vast sky or vast paradise. The name of the supercluster was chosen to emphasize how huge it is and how big this portion of the galaxy is. The Laniakea supercluster is over 520 million light-years long and has about 100,000 galaxies in it. There is a smaller group of galaxies called the local group that our Milky Way is part of. We move through space with these structures, but keep in mind that our galaxy is just a speck of sand in this huge pool of space. What are some of the biggest known buildings in this field? The Hercules Corona Borealis Great Wall and the Shapley concentration come to mind. There are about 1.4 billion light-years between the centers of the Shapley concentration. Another thing that makes the Shapley cluster look small is the Hercules Corona Borealis Great Wall, which is about 10 billion light-years long. Still, we're talking about dimensions of the universe that are hard for our minds to really picture. From Earth, astronomers try to see and study these patterns and flows of space. They are hopeful that this will finally help them figure out what the universe is for, and if there is a goal in these huge flows that will show us how the universe got here. Is the world something that lives? In the past, scientists thought that the Milky Way was the whole world. That sounds crazy now. Then, astronomers slowly started to look past the edges of our galaxy. At first, they saw nothing long, dark gaps until a new, faint glow appeared in their view. The name Andromeda was given to a cosmic fog that at first couldn't be described more clearly. It was based on a mythical Greek figure. This bright spot in space quickly became our first clear view of another galaxy. After that, many more galaxies were found, and even bigger findings were made. We have probably only looked into a small part of the world, which makes it seem even bigger than it really is. Cosmic flows are something that we've only recently learned about. They make us wonder what rules govern the directions that galaxies move. Researchers thought of the universe as a rigid structure with each star set in place as late as the 1800s. These days, we know that our solar system moves through the galaxy at about 828,000 centimeters per hour, and that the Milky Way moves through the world at only 2.1 million kilometers per hour. We live in a huge whirlpool rather than a calm building, and the way things move around must be governed by some rules. In the 1600s, Sir Isaac Newton was the first person to write down these rules of motion. Later, Albert Einstein built on these ideas to create the general theory of relativity. But so far, all of these theories have only been able to explain the things that happen in the world and the forces that cause them. They have never come close to answering the question why. More and more proof that the world is like a living thing comes from the currents and amazing structures. The 21st century scientists are now looking at the universe on a big scale to try to answer these questions. The European Space Agency's ESA Gaia Space Telescope is looking at the whole sky to do this. It is making exact three-dimensional pictures of the flow of matter and how galaxies are spread out in the universe. Euclid, which is also run by ESA, can see even more of the sky, And soon, NASA's Vera C. Rubin Observatory will be able to look at the universe 24 hours a day. Scientists want to find out what the world is all about and where we fit in it with the help of these best telescopes ever made. Gaia says amazing things about the Milky Way. Do you want to know why it's important to know where we are in this cosmic dance? It's been done more than once, and scientists have found something amazing about where the Milky Way is in the world. Being able to figure out where our home galaxy is in space is necessary to understand how other objects move and are distributed. In real life, it's not easy to see buildings with dimensions like the Hercule superclusters or the Shapley concentration. It's a barrier that we have to get past in order to see what's behind it. The search for other galaxies and much bigger formations like massive superclusters and galaxy filaments takes scientists to the very edges of the universe. It is important to keep in mind that the Milky Way is a fixed point in this view. We can only be sure of our understanding of how other structures in the galaxy move and are spread out in relation to us if we know where we are. Distortions and deflections in the data are another problem that researchers have to deal with. The universe's space is curved by the gravity of big structures. This means that we are not looking at a flat surface, but at a space that is full of bumps, barriers, and movement. It's really hard to figure out where we are and how to correctly evaluate the data. More accurate maps of the universe should lead to more accurate maps of the cosmic scenery. Ultimately, we want to use these maps to learn more about all the amazing things in the universe. The most recent results from the Gaia probe have shown us something amazing. The Milky Way may not be in the Laniakea supercluster after all. Instead, it may be in the Shapley supercluster. It was the Cosmic Flows 4 survey that made this finding by looking again at how 56,000 galaxies moved and where they were in the Gaia data. Based on these new findings, the Milky Way is part of a bigger area of attraction that changes the Shapley supercluster's gravity. However, it is still unclear whether we are really a part of the Shapley structure or whether our new location is due to the Milky Way being pulled out of its old structure by an unknown force. The Great Attractor is the only thing the Milky Way wants to reach. Let's think of the universe as an ocean that never ends, with billions of galaxies floating around like bright fish. Many galaxies are moving through space at the same time, but we can't see them. Still, many living things in the same part of the ocean move together along certain currents or share homes in the cosmic ocean. As of right now, we can see that all galaxies seem to be drawn to the same mystery point, the Great Attractor. Everything near this huge point of gravity is pulled toward it, and it affects the moves of many galaxies. You can think of the Great Attractor as a big area with so much mass that it pulls everything else toward it. So our galaxy isn't moving toward a small point, it's moving toward a place that is so mysterious that it can't be described yet. It's hard to understand things like the Hercules Corona Borealis Great Wall. This galaxy reef is just one of many structures that have been changed by the huge draw. Of course, scientists want to know how all this huge mass and gravity work. So far, all we can see is the region's strong gravity pull. It feels like there is a tornado in the vast ocean of space that pulls everything around it. That sounds both cool and creepy at the same time. We have no idea what this attraction is. The thick disk of the Milky Way still makes it hard to see the Great Attractor. Another thing that worries scientists is that they don't see galaxies and structures moving in a straight line. Instead, the center of interest makes everything else move and change in a crazy way. Besides that, we don't know if this center of attraction is really the center of the world. It's also possible that this huge magnet is just one of many in the cosmic dance. This is the dipole repeller, which works against the mysterious pull. This is also a big part of the world, but it makes things feel bad instead of good. Galaxies are pushed away from the dipole repeller, which speeds up their flow toward the center. There are hundreds of thousands of galaxies that move around these 2 points, like a magnet with 2 poles. What happens when our Milky Way gets to the attraction is the question that comes up. What happens to galaxies in the center region? Where does it go from there? This is likely something we won't be able to see until we are even closer to the magnet, or our telescopes are even stronger. At this point, we don't know what the 2 flow points are, and we can only guess that we will eventually find a whole new dimension of the world here. We could learn more about the structure and makeup of the world from a scientific point of view. If we could figure out what the attractor means, we might learn a lot about where dark matter is found and how the universe works from the Great Attractor. Some people think that the Great Attractor is more than just a huge group of galaxies, but this is just speculation and fiction. Maybe it's a place where things change, a cosmic doorway that goes to a different part of the universe. This kind of place could be like a strait in the huge ocean between galaxies, where the currents and moves of the galaxies flow. That the universe is much bigger than we thought might be the case if the Great Attractor is only one part of a bigger trip. Sign up now to make sure you don't miss any new videos.